Hello, my name is Kevin Craig. I'm in the Mechatronics studio, and this is the introductory exercise. The first part is multimeter basic measurements. We first check breadboard continuity. I set my multimeter to the continuity setting. I have a red and black cable attached to my multimeter, and at the end are mini grabbers, and attached to the mini grabbers there is hookup wire, and I'll use this for all my measurements. I go to a portion of the breadboard where there are no components. If I look at a row, I place one pin in a row and the other pin in the same row, and I push the yellow button. I hear a sound which indicates continuity. There's no continuity with another row, or in a column where that pin is, or across the divide in the same row. If I go to a power rail, this one here, and I place the pin in the blue rail and the red in the same column, I hear the signal, continuity. If I go to the adjacent column, there's no continuity. Use this technique to understand the continuity of your breadboard. Not all breadboards are the same, so it's important that you know which portions are connected to which portions. I'll shut off my multimeter. The next, we want to measure our power supply voltages coming to our breadboard. I note that I have 3 power rails. I set this up so this rail is 5 volts, this rail is minus 15 volts, and this is plus 15 volts. And this power rail, the blue column, I've connected to power supply ground, and I've then used hookup wire to connect this ground column to this ground column to this ground column, and also use this yellow wire to connect this ground column to this one here. Also notice that on each power rail I have my filtering capacitors, the 3 ceramic capacitors, and then the 3 electrolytic capacitors which are polarized. In the plus 5 volt rail, the longer leg or the positive leg goes to the 5 volts, the shorter leg with the ground leg goes to ground. In the negative 15 volt column, the longer leg goes to ground and the shorter leg goes to minus 15 volts. In the positive 15 volt column, the longer leg goes to positive 15 volts, the shorter leg to ground. These are our filtering capacitors, which we've talked about previously. To measure the voltages, I set my meter on voltage. I'll place my black wire in a ground column, and I'll first measure the 5 volts in this power rail. And you see I measure 5.030 volts. This is not adjustable, and we take what we get. This is the minus 15 volt rail, and you can see I have minus 14.84. I can adjust that on the power supply to increase that, but again, it's a very coarse adjustment. Then I measure plus 15 volts on this power rail, and you can see 14.99. These are the voltages that are coming to my breadboard. Make sure that you measure the voltages on the breadboard, so that if you're not getting the voltages, you then need to work backwards to make sure the power supply is coming to the posts on your breadboard, and then from the posts to your breadboard. I'll turn off my multimeter, I'll remove my pins. Next, we want to measure resistance. I have a resistor here, and the 2 legs of the resistors are connected to the breadboard. I connect them across the divide, one in one row, one in the other. They're not shorted because there's no continuity across the divide. I never actually put my multimeter mini grabbers on the legs of components. I use my hookup wire to make those measurements, as you will see. I'm measuring resistance, so I put my multimeter on ohms. I place one probe in one row and the other probe in the other side. So I'm measuring the resistance of this resistor, and I see 51.10 kilo ohms. I'll set my multimeter to 0 or back to alt, and I'll remove my probe. Next, I want to look at a potentiometer. A potentiometer can be either a variable resistor or a voltage divider. Potentiometer has 3 legs, top and bottom, and the middle leg is called the wiper, and it doesn't make any difference which is the top and which is the bottom, but the middle leg is called the wiper. If I measure the resistance across the top and bottom legs, I should get the resistance of the rating of the potentiometer. In this case, this is a 10 kilo ohm pot or potentiometer. So let me measure the resistance between the top and bottom legs. I'll place the potentiometer into my breadboard. I'll set my multimeter on ohms. I'll place one wire in the row with the top pin, the other wire in the row with the bottom pin, and I'll measure 9.56 kilo ohms, nominally a 10 kilo ohm pot. If I want this to be used as a variable resistor, I need to connect the wiper and the bottom leg together, short them, so I don't have a lead on the potentiometer that is floating. You can see I have this U connector that connects 2 rows together. So I'll place my potentiometer there so that the wiper and the bottom leg are connected together. If I then place one probe in the wiper and the other probe in the top leg, I can see if I then turn the screw, I can vary the resistance. As you can see, it's varying on the multimeter. The resistance will vary between 0 and the nominal voltage of the potentiometer. However, we do not want to use the potentiometer as a variable resistor within plus or minus 10% of the limiting values, because the potentiometer behaves in a nonlinear fashion in those extreme portions of the potentiometer. If I want to use the potentiometer as a voltage divider, I'll set my meter to 0, I'll remove my probes, I'll put my multimeter to another portion of the breadboard, I'll use hookup wire, and I'll connect the bottom leg of the potentiometer to ground. I'll connect the top leg of the potentiometer to 5 volts, and I will then set my multimeter to volts. I will ground my multimeter, and I'll measure the voltage at the wiper. And I see I measure 2.102 volts. So by turning the screw, I can measure voltages between 0 and 5 volts. So this now becomes a voltage divider. I'll set my multimeter to off. I'll remove all my probes, and I'll remove my hookup wire. Next, we want to measure capacitance. I have 3 capacitors. I have a electrolytic, a tantalum, and a ceramic. Both the electrolytic and the tantalum are polarized. The longer leg is the positive leg, but if the legs have been cut for some reason, then look at the housing, because the positive leg is identified on the capacitor housing. Ceramic capacitor is not polarized. To measure capacitance, I set my multimeter on the capacitance setting, and I need to move my red cable to the other side of the multimeter. I'll set my black probe on the ground leg of the capacitor, of the electrolytic capacitor, a red probe on the positive leg, and I will measure then, you see, 0.987 microfarads. If I do the same for the tantalum capacitor, I measure, and we see 7.22 microfarads. And the same for the ceramic, capacitor, I measure 12.51 nanofarads. I'll set my multimeter to off, and I'll remove my probes. Next, we want to measure inductance. This is an inductor. It's a coil of wire. It has two leads. The coil of wire has inductance, but it also has significant resistance. So we also want to measure the resistance of our inductor. I place my inductor in the breadboard again so the leads are not shorted. My probe is in the proper setting for inductance, and I'll move my multimeter to the setting for henries, which is the unit of inductance. And I'll use my probes, and I'll place one probe in the row with one wire, and the other probe with the other wire. And I think I have them in the right places. Maybe I don't. So I'm going to make sure I do. There we go. So I measure 0.303 henries. Now if I want to measure the resistance, I need to move my probe to the other side, my multimeter cable to the other side, and I need to put my multimeter on the ohm setting. And I measure the resistance of my inductor to be 65.8 ohms. So if the other resistances in your electrical system are comparable, then this can't be neglected. If the other resistances are kilo ohms, then this is insignificant. I'll set my multimeter to off, and I'll remove my probes. Next, we want to check the operation of a diode. This is a diode. The diode behaves like a check valve in hydraulics. The diode allows current to flow in one direction, in this case from right to left. The white band indicates the direction of current flow. Current will flow from right to left, but not from left to right. So I'll put my diode, use the diode setting on my multimeter, and I can then use my two probes. I'll place the red probe on the right lead and my black probe on the left lead. And you can see I measure a voltage drop of 0.561 volts. That indicates current is flowing from the right to the left, and that's the voltage drop across the diode. If I change the probes, put the red on the left and the black on the right, no current will be flowing, and the overload setting on my multimeter indicates that no current is flowing. I'll set my multimeter to off, and I'll remove my probes. Next, we want to check the MOSFET. This is a transistor, metal oxide semiconductor field effect transistor. This is the front of the transistor. This is the back. They're different, so it's easy to identify the front. On the front, you can see we have 3 pins from left to right. Pins 1, 2, 3. Gate, drain, source. Gate, drain, source. I'll place my transistor in my breadboard so none of the pins are shorted. Now, to test the operation of the transistor behaves like a switch. I'll use my hookup wire. So I'll connect the source. I will connect to ground. And I will connect my gate, the top pin, I'll connect that to 5 volts. Now, if I measure the continuity between what? Between the gate, between the drain and the source, I should have continuity. I'll set my multimeter on the continuity setting. I'll place one pin in the source, the other pin in the drain. Hit the yellow button, and I have continuity between the drain and the source when the gate gets 5 volts. If I change the gate to ground, I have an open circuit. So the transistor is functioning properly. I'll set my multimeter back to off. I'll remove all my hookup wire. I'll remove my multimeter probes. Lastly, we have an op amp. An op amp is, as shown here, an op amp is a black box. We treat it like a black box. It has many, many transistors and resistors in it. We just need to know how to use it for various operations within its capacity. You can see the op-amp has, if I turn it over, you can see it has 8 legs. The top of the resistor, or the top of the resistor, is indicated with a little circle or an indentation. The pins are numbered from the top counterclockwise, 1, 2, 3, 4, 5, 6, 7, 8. When you mount the op-amp on the breadboard, so you don't short pins 1 and 8 and so forth, you need to place it across the divide. Sometimes the pins fit easily, as I'm going to do right here, but if they don't fit easily, don't force them. You can grab the op-amp and just squeeze the pins together a little bit so they line up better with the holes. And again, with a little care, which is taking me a little bit longer because one of the pins is bent. If one of the pins gets bent, you can straighten it out. Just do it with care. You can see I'm having a little tough time with this because one of the pins is bent a little bit. But again, with a little care, you can straighten it out. And I'm having a bit of difficulty with this, but there we go. Now I have it in. So you can see it can take some time. You have to do it with care. Align the pins. The pins will bend really easily, so you don't force it in because the pins will break. I have my op-amp here positioned already, and I'm going to use it in what we call the buffer mode. And in the buffer mode, the input equals the output. So in the buffer mode, the pins are as such. 1 is not connected. 2 is your inverting input, and it's connected by this white wire to pin 6, which is my output. Pin 3 is the non-inverting input, and I'll connect this to 5 volts. Pin 4 is the minus 15 volts, and I connect it to minus 15 volts. Pin 5 is not connected. Pin 6 is my output, which is connected to the inverting input, which is pin 2. Pin 7 is positive 15 volts. With the power supply on, and I measure volts. If I measure the voltage at the output of the op-amp, I'll ground this, my multimeter pin, and measure the output voltage. I am measuring minus 12.71 volts, which is not correct. Because I'm not giving my op-amp plus 5 volts. Plus 5 volts is over here. So if I give it 5 volts, I can see that I'm getting the output. I can't give the op-amp more voltage, in this case 15 volts, more than I'm supplying to it, because this is an active component. It needs voltage to function properly, so I need to give it 5 volts. So if I use my multimeter, 5 volts is the input, 5.030. And if I measure the output of the op-amp, there's the output, and it's the same. So the op-amp is working in its buffer mode, and it's functioning properly. This concludes the multimeter basic measurements of the introductory exercise, which is part 1. Thank you very much.